Okay, we have talked about how to solve linear equations, systems of linear equations by graphing and substitution. Now we want to go ahead and look at the elimination method. Now before we can get started with the elimination method, there are some basic things that I want to talk about that will help us when we do the elimination method. So let's go ahead and take a look at some properties here. Now we have the idea is if you have two quantities equal to one another, like you have A equals B here, we are saying if A equals B, then A plus C equals B plus C, where you are adding the same quantity to both sides of your equality right here. And we are saying adding the same quantity to each side of an equation results in the equal sum. So the idea is if you already have an equation and add the same quantity to both sides, your results will be the same, equal sums. Now let's look at another property here. This one talks about if A equals B and C equals D, so you have two equations, then A plus C equals B plus D. So you're just basically saying if you take A plus C, that will equal B plus D from your two given equations. So this property basically says if you are adding equal quantities rather than the same quantity, okay, so you are adding equal quantities and not the same quantity like we did here in the first property to the equation, to each side of an equation, that also results in equal sums. Okay, so you have these two properties here where you add either the same quantity and you still end up with equal sums, or you can add equal quantities to each side of an equation, and that will also result in equal sums. This last property that we talked about is what is known as the addition property, and we are going to use the idea of the addition property to help us solve the linear systems in the elimination method. Okay, so you want to keep that property in mind when we are working with this elimination method here. So let's go ahead and look at an example on how the elimination method works. So we have these two systems here. These two equations in our system here, x plus y equals 10 and x minus y equals 6. So if we were trying to use the addition property that we just saw, the idea is we will go ahead and just like we did here, you had your two equations, go ahead and add the left hand sides together and then go ahead and add our right hand sides together. So if I add my x plus y with the x minus y, and on the other side go ahead and add the 10 with the negative 6, let's go ahead and see what do we end up with. This will give you x plus y plus x minus y equals 10 minus 6. Now you have a plus y, a negative y. They will cancel out, and you can see with the elimination method we just are left with the two x values here and your real number on the other side. So that will give you 2x equals 4. Go ahead and solve for x, move your 2 over to the other side, and you will end up with x equals 2. So as you can see with the elimination method, you are basically eliminating one of the two variables and solve for the other. Now that we have x equals 2 here, we can go ahead and find our y by substituting for our x value. So we'll go ahead and let's say use our first equation here, x plus y equals 10, to find our y variable here. So x equals 2. Go ahead and get y by itself, and you will see you end up with y equals 8. Now that we have our x and y values, let's go ahead and check our solutions in both of these equations right here and make sure that you end up with a true statement for both of them. So your first equation is x plus y equals 10, and your other equation is x minus y equals negative 6. So you had x as 2, y as 8, so 2 plus 8 of course gives you 10, and you can see you end up with a true statement on the first equation. We'll do the same thing for the second equation here. Go ahead and substitute your x and y values, and again we end up with a true statement for both our equations. So now we can say, since the ordered pair 2, 8 satisfies both our equations, your solution set for this system is your ordered pair 2, 8. So this was just a basic example of how the elimination method works. Now let's go ahead and take a look at the steps involved in working with the elimination method, and then we'll go ahead and look at a couple more examples. Now, when you are solving a linear system by the elimination method, the first thing you will do is write both your equations into standard form. Now your standard form, of course, is the form ax plus by equals c. Okay, so that's the first thing we will do. Then your next step in your method here is basically you have to transform your coefficients, transform so that the coefficients of one pair of variable terms are opposites. Okay, so if you want to take the x variable, make sure that the coefficients on the two x variables are opposites. So multiply one or both equations by appropriate numbers so that the sum of the coefficients of either the x or the y terms is 0. Okay, so you want the variable coefficients to be opposites, and you can do that by multiplying either one or both equations by the appropriate numbers so that when you add the two coefficients together, their sum is going to be 0. Okay, that's your second step involved in elimination. Now let's go ahead and look at our other steps here. With step 3, you will go ahead and add the new equations that you have transformed in step 2. You'll go ahead and add the new equations to eliminate one of the variables. The sum should be an equation with just one variable. So once you eliminate one variable, your final sum should have only the other variable left. Your step 4, solve the equation from step 3 for the remaining variable, just like we did in our example where we eliminated y and then solved for x. Then your step 5 involves where you will substitute the result which you found in step 4 here into any one of the two original equations and solve for the other variable. And then of course the last step involved would be where you will check your solutions in both the original equations and then write your solution set. Now it really does not matter which which variable is eliminated first. You can work with any one of the two variables. Just choose the one that would be convenient to work with, and you can go ahead and eliminate that variable.